Deep learning, powering AI and reshaping education. Hello and welcome everyone. Are you curious about how artificial intelligence or AI is transforming the way we learn and teach? Have you ever wondered about the magic that powers AI? Well, today, we're diving deep into deep learning, the driving force behind many advancements in AI. We'll explore how it operates, and more excitingly, how it's revolutionizing education and setting the stage for the classroom of the future. Deep learning is a subfield of machine learning, which is essentially a neural network with 3 or more layers. These neural networks attempt to simulate the behavior of the human brain, albeit far from matching its ability, in order to learn from large amounts of data. While a neural network with a single layer can still make approximate predictions, additional hidden layers can help optimize the accuracy. Here's a breakdown of its key characteristics. Layers of neurons. Deep learning uses artificial neural networks, ANNs, that are modeled after the human brain. These networks have several interconnected layers of neurons, or nodes, that pass data between each other and adjust their synaptic weights, the influence of a particular node's output on the next node's output, to better predict the correct outcome. Training and learning. During the training process, the neural network's weights are adjusted in order to reduce the difference between the predicted output and the actual output. This process is called backpropagation. The network learns from its mistakes and improves over time. Data representation. Deep learning networks can automatically learn to represent data by training on a large amount of data. This representation learning is particularly effective when dealing with high-dimensional raw data, such as images, audio, or text. End-to-end learning. Deep learning can perform end-to-end learning, where raw data such as pixels of an image can be input directly into the neural network, and labels can be output directly, eliminating the need for manual feature extraction which is necessary in traditional machine learning models. Deep learning has been used for various tasks, including image and speech recognition, natural language processing, social network filtering, machine translation, bioinformatics, drug design, medical image analysis, and many others. How does deep learning power artificial intelligence? Deep learning is a key technology behind the advancement of artificial intelligence, AI, especially for tasks that involve recognizing patterns in large amounts of data. Here's a simplified explanation. Data processing. At the most basic level, deep learning models are designed to automatically extract and learn useful features from raw data, which is a process that typically requires significant human effort in traditional machine learning models. This feature learning capability allows deep learning models to handle diverse and complex data types like images, sound, and text. Artificial neural networks. Deep learning models are built upon artificial neural networks, ANNs, particularly deep neural networks, DNNs. These DNNs have many layers of interconnected nodes, also called neurons, that work together to make sense of the input data. They can learn and refine their understanding of the input data over time, allowing them to perform complex tasks like image and speech recognition, natural language processing, and more. Learning from data. Deep learning models learn from data through a process called training. During training, the model is fed large amounts of data and the corresponding labels, for supervised learning, and it adjusts its parameters to reduce the difference between its predictions and the actual labels. This process can be thought of as the model learning to recognize patterns in the data. Enhanced capabilities. Deep learning, through the use of these deep neural networks, has greatly enhanced the capabilities of AI. Tasks that were previously considered difficult or impossible for computers to perform, like translating spoken language in real time or recognizing objects in images, are now possible due to deep learning. How deep learning could impact education. Virtual tutors. Deep learning can be used to create intelligent tutoring systems that can interact with students in a manner similar to a human tutor. They can guide students through complex problem-solving tasks, provide personalized feedback, and adjust instructional strategies based on individual student needs. Learning analytics. Deep learning can analyze data collected from online learning environments to uncover patterns and insights about student behavior and learning processes. This can help educators to optimize course designs, teaching strategies, and assessment methods. Adaptive learning platforms. Deep learning can power adaptive learning platforms that deliver personalized learning experiences. These platforms can dynamically adjust the difficulty level of learning activities, provide targeted feedback, and offer personalized learning paths based on each student's knowledge level, learning pace, and learning style. Real-time speech translation. Deep learning can be used to develop real-time speech translation systems that can remove language barriers in education. This can enable students from different countries to participate in the same online class or help students learn new languages. Content recommendation systems. Similar to how Netflix or Amazon recommends movies or products based on your past behavior, deep learning algorithms can recommend educational content, e.g., books, articles, videos, tailored to each student's interests, academic goals, and knowledge gaps. Automated grading. Deep learning technologies can also be used for automated grading of multiple choice and fill-in-the-blank tests. Further advancements are being made in grading of essays and written responses, though these are more complex and challenging tasks. Enhanced engagement. Deep learning can be used to develop sophisticated educational games and simulations that adapt to the learner's level, creating a more engaging and interactive learning environment. Sentiment analysis. Deep learning can analyze students' feedback, forum posts, or communication to detect their sentiments and emotions, which can help educators understand how students feel about a course, a teaching strategy, or an educational policy. Facial recognition for attendance. Deep learning can be used to develop facial recognition systems for tracking student attendance, ensuring security, and even monitoring student engagement during online classes. And that's a wrap. Today, we ventured into the world of deep learning and saw how it powers AI by processing massive amounts of data and learning much like the human brain. Remember, this is just the tip of the iceberg. There's so much more to deep learning and AI, and their applications are only expected to expand and become more sophisticated. Stay tuned for our next episode, where we'll explore more fascinating topics from the world of technology and education. Don't forget to like, comment, and subscribe if you enjoyed this video. Until next time, keep learning, stay curious, and embrace the future.